Welcome back to Business Time. I am Melisha. If you have not yet subscribed to my channel, please do so. And also remember to like and share. Now we're going to be looking at question 1 of the Management of Business Unit 2, Paper 2, and we'll also be looking at how to do the critical path method. All right, let's get right into it. Now, the case says Bob Anderson is the owner or manager of Andy's Beverages. The firm produces drinks from locally grown fruits and vegetables for the domestic and overseas markets. There is increased demand for the local products. Bob therefore wants to add a new line of product called nutraceutical juices. Andy's Beverages currently uses the batch production process. In order to meet the expected demand for the new product, Bob will have to find a new location for the business. Now, the first question, A1, says, define the term batch production. Take a few seconds to think about it. This is a process where identical products are produced in a set or batch. These set of products are produced in bulk and go through the different stages of the production process at the same time. For example, a batch of chocolate cakes. So all the chocolate cakes will go through the same process at the same time until they are finished. And that is 2 marks. All right. Let's look at the next question. Outline one cost factor that Bob would have to consider when relocating Andy's Beverages. Can you think about it? All right, let's look at a possible answer for this. He will need to find out if there is adequate infrastructure in the area that he wishes to locate his business. If there's electricity, water, he will not have to spend a lot of money to get these to the business place, right? Other cost factors could be cost to rent or purchase a property, closeness to the market, government incentive for setting up in a particular area, and so on. All right. Let's look at the next question. Bob wants to know if the fixed layout strategy for the product expansion he is planning would be best for the business. Explain 2 advantages and 1 advantage to the firm if Bob chooses to use the fixed layout strategy for the proposed venture. Take a few seconds. Can you come up with 2 advantages and 1 advantage? All right, let's look at a possible answer. So advantages, the first one, there will be increased efficiency. Having all the materials, equipment, and workers in the same location will allow for better workflow, and this could allow workers to work at a faster pace, which could result in a greater level of productivity. The second advantage, reduction in the movement of products. So because the products will be manufactured at the same location, there will be less wastage of resources or damage to products. This will help to reduce the operational cost of the business. Let's look at a possible disadvantage: increased labor cost. Because such a strategy requires highly trained workers with multiple skills, the business may have to prepare to spend more money to get these skilled workers. This is because all different categories of workers will need to be on site to get the goods produced with the highest possible quality. All right, so question C is the critical path method. And it says, Andes Beverages decides to use the critical path method to estimate the time required for the nutraceutical juices project. The information for the tasks to be undertaken and their duration are provided in figure 1. So here's figure 1, where they've worked out most of it already, and where you see the missing numbers, you're going to have to figure that out. Now, even before I just go ahead and give you the answers, I'm going to discuss the critical path method so that you'll have a better understanding. So if you're asked to create one from scratch, from the very beginning, you should be able to do it, and also you'll be able to confidently arrive at the missing numbers. So let's go over. We're going to leave this a little bit, and we're going to discuss the critical path method. How is it calculated? How is it done? All right, so let's get started. So it's very important that you understand nodes that come with the calculation of the critical path method, right? So when you see one looking like this, it's important that you know what each of these stand for. So the EST stands for the earliest start time. That is the earliest time that an activity can start, right? The LST stands for the latest start time. And the A stands for the activity. That is what is to be done on the project, right? And the T stands for the duration of the activity. How long is the activity going to take? Is it going to take 2 weeks, 1 week, a day, a month? So duration of the activity is important. The EFT stands for the earliest finish time, the earliest time that the activity will finish. And the LFT stands for the latest finish time, the latest time that an activity can finish. So it's important that you understand each of these and what these stand for. I just created a table for the exam question. It could have been set out like this, just like you see this table at the bottom, the exam question. So I just drew up the table from the chart that's on the exam paper. That is to show that you could have gotten a table like this and you had to draw it like it's presented on the exam paper. So you see you have activity, the preceding activity, meaning what must be done before that activity, the next activity, and how long the activity is going to take, the duration. So for activity A, we see that it will take duration 5 weeks. For activity B, we see that it will take 6 weeks, right? And for activity C, we see that it will take 4 weeks. So remember, you have the duration at the bottom, how long the activity is going to take, and at the top, it's the name of the activity, right? For B, we see that activity D is going to take 6 weeks. And you will see that an arrow is drawn here as well from C to D, which means that D can only start after B and C are completed, which is what you're seeing here. And activity E can start after C. And you see here that the duration, how long is activity E going to take? 5 weeks. E, you see it on the table here, 5 weeks. Activity F is going to start 8 weeks. However, it's important to take note, as you see on the table, that activity F cannot start until D and E are finished, right? So even if E is finished, as you can see here, that E is going to take 5 weeks, it still does not mean that you can start F, because you have to wait until D is finished before you can start F. So that's just how to interpret. By just looking at this, you should be able to understand what it is saying. Now, let's see if we can complete this. Because remember, you need to know how to work it out so that you can get the correct answer on the exam paper. So there's no preceding activity for A to start, right? So remember, this first box here is the earliest start time. So I mean, there's nothing before, no activity before A, so it's going to be 0. Earliest start time, you know, for A. So let's look at B now. What is the earliest start time for B to start? Now, A is going to take 5 weeks. So B can start at 5 weeks. That is the earliest start time, right? 0 plus 5 gives you 5 weeks. That's the earliest start time for B. Now for C, what is the earliest start time for C? Think about it. How long will A take? 5 weeks, right? And so C can start at 5 weeks. Now, let's look at D. It is obvious that D will commence after B is finished and C is finished. Because, how do we know that? Because we see the 2 arrows here towards D. This is showing that D is dependent on B and C to be completed. Good. Now, even if one of these B or C finishes before the other, this activity D still cannot start until the other is finished. Okay, so here is it that B will take 5 plus 6, call that 11 weeks. You add the 5 and the 6, 11 weeks to complete. Good, because remember, A is going to take 5 weeks and B is going to take 6 weeks to finish. So that's 11 weeks. Let's see how long C is going to take. Remember, 5 plus 4, that's 9. And so guess what? Even though C is going to finish in 9 weeks, we still cannot start D until B is finished, which would have taken 11 weeks. So the earliest start time for D is 11 weeks. Now, E only needs to wait on C. Therefore, the earliest start time will be the 5 weeks for A and the 4 weeks for C. So the 5 plus 4, that's 9 weeks. And so the earliest start time for E is 9 weeks. Now, look at F. F cannot start until D is finished and E is finished. So we need to know which is going to take the longest, because it's the longest time that it will take for F to start, right? So D will take 11 plus 6. That is how many? 17 weeks. How long will E take to finish? 9 plus 5. That is 14. And so even though E will take 14 weeks to finish, F still cannot start. Why? Because D is going to take 17 weeks to finish. So that's the earliest start time. Now, 2. So remember now, so this here means earliest start time. This means the activity, and this one here means the earliest finish time. Good. So the earliest finish time for A, we know it is going to be 5 weeks, right? Because that's how long it's going to take. 5 weeks. The earliest finish time for B, it's going to take 5 plus the 6. That's going to take 11 weeks. The earliest finish time for C, it's going to be 9 weeks. So 5 plus the 4, that's the 9 weeks. So the earliest finish time for D is 17 weeks. 11 plus 6, 17. The earliest finish time for E is 9 plus 5, that's 14 weeks. The earliest finish time for F is 17 plus 8, that's 25 weeks. Now let's see if we can find out what the latest finish time is for these activities. So we have left to calculate the latest finish time and the latest start time. So this section here is the latest finish time, and remember this one is the latest start time. So the latest finish time for F will be 25, right? Because it's just when it can, there's nothing else to come after this or nothing else to come before this. So the latest finish time really is 25 weeks, especially since we have taken into consideration all the previous week activities and how the longest time that those activities will take. So to find the latest start time is to take the duration from the latest finish time. So for F, it will just be the duration is 8. Take that away from the latest finish time. 25 minus 8, that gives you 17, and that's how you'll end up with 17 being the latest start time. And that is true because when you think about it, the 17 has to be the latest start time, because you could not have started E before D, right? And so you just had to, because the earliest finish time for D would have been 17 weeks anyway, right? So as we continue to find the latest finish time for E, it will be 17 weeks, as F has to start in 17 weeks. The same will go for D. Just latest finish time. The latest start time for D, remember what I said you are to do? You take the duration from the latest finish time, 17 minus 6, and you get 11. Same thing for E, 17 minus 5, and you get 12 weeks. The latest finish time for C will be 11 weeks because D had to start in 11 weeks. Same for B. Remember, D was dependent on B and C to finish. The latest start time for C, remember our formula? 11 minus 4, that will give you 7. So it's 7 weeks. 7 weeks is the latest start time for C. For B, the latest start time is 11 minus 6. That is 5. So you get 5 weeks. Latest finish time for A is 5 weeks, as B and C will start in 5 weeks. And to get the latest start time for A, remember 5 minus 5, that is 0. So let's look back at the question, bearing this in mind now. First question, complete the network diagram provided in figure 1 by inserting the missing start and finish times for each task with a blank slot. So we would have done that already, right, by putting in the missing slots. For F, we are 25, 25. For E, we put in 17. And for B, we would have put in the 11. Good. So the next question says, state the length of the project in weeks. Now the length of the project in weeks will take what? 25 weeks. 25 is the earliest finish time and the latest finish time as well. So the project will take 25 weeks. So the next question says, determine the critical path for the project. So when you're going to determine the critical path for a project, there are two ways that you can go about doing this, right? The first thing you can do, is look for the longest path on the project. So to look for the longest path on the project, right? So in this case, so you have path A, B, D, F, and another path A, C, D, F, and then another one A, C, E, F. Now, all right, so let's see if we can put that down using this easy method. So for path A, B, D, F, let's look at it. A, the duration for path is 5, right? 5 weeks. The duration for B is 6 weeks, right? Duration for D is 6 weeks as well. For D is 6 weeks. For F is 8 weeks, right? So how many weeks will we get for that? 5 plus 6 plus 6 plus 8, that's 25 weeks, right? So we're saying that's 25 weeks. All right, so let's look for the other path now. A is, so we're going to look at path A, C, D, F. A is 5 weeks. C is 4 weeks. D is 6 weeks. F is 8 weeks. How many weeks is that? That's 23 weeks. Good. Let's look at the other path now, which is ACEF. So A, 5 weeks. C, 4 weeks, right? That's how long it takes. E, 5 weeks. F, 8 weeks. So the total for that is 22 weeks. Oh Lord, this should have been 25. What did I have here? 55. That should be 25 weeks. So by trying to figure it out this way, we'll realize that the critical path right here is A, B, D, F. That's the quickest way to look at it. But there's another way that we can calculate it, and that is where we have to calculate the slack time. Good? So remember that the slack time looks at how long the activity can be delayed without extending or increasing the project completion time. Good? So to calculate the slack time, there is a formula. So take note of this. Let me jot this down here. Slack time is equal to latest start time minus earliest start time. Good. So remember that to calculate the slack, it is the latest start time minus the earliest start time. So remember now that the latest start time is at the bottom left, right here, and the earliest start time is the one at the top. Good. So for us to know what the slack time is for A, we're taking the earliest start time from the latest start time. So remember, the earliest start time is the one at the top, and the latest start time is the one at the bottom. And so for A, it would be 0 minus 0, that is equal to 0. So the slack time is 0 weeks, right? So there's no slack time on this. So let's see if we can calculate now the slack time for B. So remember, we're taking the earliest start time from the latest finish time, right? So you see, they have the same number, right? So still 5 minus 5 equals 0. So B has 0 slack time. For C, so remember, we're taking the earliest start time from the latest start time. So the latest start time for C is 7 minus the earliest start time is 5. That is equal to 2. Let's look at the slack time for D. 11 minus 11. That is equal to 0. For E, it's 12 minus 9. That's equal to 3. Good. For F, it is 17 minus 17. That's equal to 0. So, which path is the critical path now? So if we look at path A, B, D, F, see, all of that is 0. True? If we look at path A, C, D, F, we'll see that that is A0 plus 2 plus D plus F, right? So let's write these down. So remember, we're determining the critical path. So path A, B, D, F is equal to 0 plus 0 plus 0, 0 plus 0 plus 0, 0 is equal to 0 weeks, yeah? Let's look at A, C, D, F, right? A, C, D, F, so that's 0 plus 2 plus 0, 0. 0 plus 2 plus 0 plus 0, that's equal to 2 weeks. All right. Path looks like path ACEF. That is 0 plus 2 plus 3 plus 0, that's equal to 5 weeks, right? So we see that the critical path is ABDF because there's no time for any delays, no errors, no mistakes, right? When we use this method, activities with 0 slack time are along the critical path. All right, so those are the critical activities, meaning that there's no room for delay. So let's go back to the question. Determine the critical path for the project. So the critical path for the project is ABDF. Calculate the slack time for each path. So we had done that already. The slack time, ABDF, that's equal to 0 weeks. ACDF, that is equal to 2 weeks. And ACEF, that's equal to 5 weeks. And the final question for this section, if task F were delayed by 2 weeks, state what that would mean for the completion of the project. Simply put, the project will be delayed by an additional 2 weeks. So you could also put that instead of the project finishing in 25 weeks, it is going to end up finishing in 27 weeks. Okay? So, hope that you learned something. See you next time.